Question 6. Are covalent bonds likely to form between metals? And explain why. For the sodium atom, it is much easier to give away its one electron than to form 7 covalent bonds. If the sodium was to form covalent bonds, it would have to form 7 of them. Otherwise, you wouldn't be able to gain stability. In chemistry, usually the lowest energy path is the most likely. So in many sciences, many physical sciences, taking the lowest energy path is usually the most likely. For instance, if I had a rock or a little ball at the top of a hill and it fell down, it would roll down the hill. Now, if I had a ball at the bottom of the hill, it's not going to roll up the hill by itself. So you can see that that's just one example of the lowest energy path being the easiest and the one that usually happens. It might roll up the hill by itself, but it's very, very, very unlikely. What conditions are required then to form covalent bonds? Okay, so the question after the previous question is a pretty logical one. What conditions do you actually need in order to form covalent bonds? Well, what we want is 4 or fewer electrons needed to form the stable octet. To form covalent bonds, we require 4 or less electrons to make the stable octet. So in other words, it has to be group 4 or higher. Participating atoms must not be strongly electropositive. So they don't want to give electrons away readily. Okay, they want to take in electrons. So for the participating atoms, we need the electrons to be not electropositive, hopefully electronegative. So those are the conditions that we require. So draw the Lewis dot diagram for the formation of the oxygen or O2 molecule. So oxygen is in group 6. So we represent as 2 O's with 6 dots or X's around them. If you count them out, there's 6, okay? 1, 2, 3, 4, 5, 6. Same with this one. Now you can see there's 2 that aren't sort of paired together. So they're going to form our bonds. So you can see that this one joins this one, and this one joins this one, and they kind of come to the middle and form 4 electrons, so 2 bonds, and that's our oxygen molecule. So that's a common double bonded structure. So question 9, a covalent bond is formed when a pair of electrons is shared. Now electrons are both negatively charged, so they should repel one another. So how does this pairing of electrons hold atoms together then, if they're going to just repel each other anyway? Now the electrons in a covalent bond are usually found between the 2 nuclei of the participating atoms. Okay, so if this is the nucleus, and this is the other nucleus, you'll usually find the electrons sitting somewhere there. At this location, the nuclei, being positively charged, are attracted to the concentration of negative charges. So if I'm a nucleus, I see these 2 negative charges and I'm attracted towards them because there's suddenly this big negative charge in the middle. And if I'm on this side, I'm attracted this way. So we're both being attracted this way. So you can see that they're instantly holding these 2 atoms together because they're pulling the nuclei closer together. And that's essentially how they keep the 2 atoms together. Now this tends to bring the nuclei closer together, as I mentioned, and that helps to hold the electron or the atoms together in the greater structure. So that's how covalent bonding works. And finally, question 10. Nitrogen gas, N2, forms when 2 nitrogen atoms bond to one another. How many covalent bonds do they form? And does this explain why N2 gas is a very inert gas? Inert meaning it doesn't react with anything. So nitrogen atoms have 5 valence electrons. So each nitrogen atom has 5 electrons in its outer shell. Therefore, they require an additional 3 electrons. Now this means if it was to bond with another nitrogen atom, it can form a total of 3 covalent bonds, or a triple bond. What it will do is it'll form like that. And there'll still be 2 electrons on either side. So that's what it looks like. Now this triple bond structure makes it incredibly inert as 3 bonds need to be broken in order for this N2 to react with any chemicals. So when you react things, you need to break them apart completely. If you want to break this molecule up, you'll have to break through 3 bonds. And breaking through 2 bonds or 1 bond is hard enough, then breaking a 3rd bond will be very, very difficult. And it does happen. Breaking these triple bonds does happen naturally. Lightning strikes will break these bonds, but if you imagine what a lightning strike is, it's a huge amount of energy. Additionally, if you're in an industrial setting, if you're driving your car along and you've got a very high performance car, the heat of the engine can actually get high enough that you start breaking up these bonds and forming other substances. You will form triple bonds and that is why they're very inert, but there are cases where you can break them up. So that concludes today's lesson on covalent bonding. We looked at what covalent bonding is and how we form covalent bonds and what are the conditions for covalent bonds forming. So in the future lessons, we'll look at other types of bonding like metallic bonding, and we'll look at how these bonding structures influence the properties of these chemicals. So look forward to seeing you at our next lesson.